Hello everyone, my name is Rakryan Karim Djohar. Here I am to explain the first few topics of systems of linear equation. First of all, we have the definition of linear equation, which is told that is a linear equation is an equation where all variables are to the first power, and the graph of it is a straight line, where a1, a2 are coefficients, x1, x2, all the way to xn are variables. B is a known constant. For row operations, there are three rules you can apply to a matrix to simplify it without changing the solutions. So first of all, we have swap two rows like this, multiply a row by a non-zero number, and also you can add a multiple of one row to another. I will be explaining the REF and RREF. REF is row echelon form. It is a simplified version of a matrix. A matrix is in row echelon form if 1. 0 rows if any are at the bottom. 2. The pivot leading entry of each non-zero row is to the right of the leading entry of the row above it. And 3. The entries below each pivot are all zeros. For RREF, which is reduced row echelon form, it is the most simplified form of a matrix, and a matrix is in RREF if it satisfies all of these conditions. Number 1 is all zero rows if any are at the bottom. Number 2, the pivot in each non-zero row is 1. Number 3, each pivot is the only non-zero entry in its column. Number 4, each pivot is to the right of the pivot above it. Next up is the general definition of matrix and vectors. Matrix is a rectangular array of numbers or functions arranged in rows and columns, seen as this. The three core functions of a matrix are solve systems of linear equations, perform linear transformations on vectors or spaces, and store and manipulate multivariable data efficiently. Next up is a vector. A vector is a list of numbers called components arranged in a column or row used to represent a point, direction, or quantity in space. Column vector is default in matrix by multiplication. Row vector is often used in dot product or transpose.
Hi everyone, my name is Danish. So today we will explain about the Gaussian elimination and Gauss-Jordan elimination. Okay, first, for Gaussian elimination is a method for solving system linear equation in two steps. First, we convert the system augmented matrix into row echelon form, and then second, we use back substitution to find the solution. Okay, let's solve this example. X plus y plus z equals 6, and then 2 plus 3 y plus z equals 14, and then x plus 2y plus 4z equals 20. Okay, we write this augmented matrix for the system. It looks like this. And then now start eliminating for row 2. And then we do row 2 minus 2 times row 1. And then for the row 3, we do row 3 minus row 1. Okay, that gives us a new matrix like this. So, next we subtract the row 2 from row 3. And then now we have the matrix in row echelon form. This looks like this. Okay, time for back substitution. From row 3, we got the 4z equals 12, so z equals 3. Okay, from row 2, we have y minus z equals 2, so y equals 5. From row 1, x plus y plus z equals 6, and then that means x equals negative 2. So that the final solution is x equals negative 2, y equals 5, and z equals 3. Okay, now let's move to Gauss-Jordan elimination. Okay, this method is similar to Gaussian elimination, but instead of stopping at row echelon form, we go all the way to reduce row echelon form. That way we can reach the solution directly without the S function. Okay, here is the example. Now, from this we write the augmented matrix for the system. This looks like this. And then first we eliminate below the pivot in the first column, and next we eliminate using the pivot in the second row, and then we scale the third row to make the pivot 1. finally, we eliminate above the third python. Now the matrix is in reduced row echelon form. From here, we can read solution directly. x1 equals -1, x2 equals 1, and x3 equals 2.
Today we're going to learn about systems of linear equations and how we can represent them in matrix form. System of linear equations is simply a set of two or more linear equations that involve the same variables. For example, take a look at this system. Here we have three equations and three unknowns, x, y, and z. Our goal is to find x, y, and z that satisfies all three equations at the same time. Now, instead of writing all three equations like this, we can represent them in a contact form using matrices. This is called the matrix form of a system of equations written as this. Here's how that looks. A is called the coefficient matrix. It contains all the numbers in front of x, y, and z from the equations. X is the column vector of unknown variables. This is what we're trying to find, x, y, and z. B is the column vector of constants, which comes from the right side of the equation. In this case, 12, 13, 1. So, our three equations can be written as this. This is a much cleaner and more compact way to work with systems of equations, especially when we have lots of variables. So whether we write it as this, so whether we use separated equations or in matrix form, is describing the exact same problem, finding x, y, and z that satisfies all equations. Thank you.
So today I'm going to be explaining about the types of solutions to system of linear equations. So when solving a system of linear equations, usually involving three variables in 3D, you're essentially trying to find where multiple planes intersect. There are only three possible types of solutions. So the first one is the unique solution, where there is exactly one solution. In this case, all three planes intersect at a single point in space. The point is the only solution that satisfies all three equations. Geometrically, it's like the sweet spot where all planes meet, and it's only one point. The second one is infinite many solutions. Here, the three planes intersect along the same line. That means there isn't just one solution, but an entire line of points where all equations are true. This happens when the equations are dependent. Some equations are a combination of others. And the third one is no solution. In this case, the planes do not intersect at any point at all. Often they are parallel or skewed so that no single point exists on all three. Thank you.
Hello everyone, today I'm going to explain about homogeneous system of linear equation. A homogeneous system of linear equation is set of linear equation where all constant terms are zero. You can see this example from your image right here. Notice how the right side of every equation is equal to 0. This can also be written in matrix form as AX equals 0. A homogeneous system has only two possible types of solution. One, a single solution, or you can call it trivial solution. The only solution is when all the variables are equal to 0. This is called the trivial solution because it always exists for any homogeneous system. 2. Infinitely many solution. This happens if there is at least one free variable. If there is a free variable, it means there are many solutions besides the trivial one. Okay, now I explained homogeneous system. Now I'm going to explain free variable. A free variable is a variable in a system of equation that does not have a pivot in the row echelon form of the augmented matrix. To find free variables, you can follow these steps. 1. Write the augmented matrix for your system of equation. 2. Reduce the matrix to its reduced row echelon form or RREF. 3. A variable is considered free if its corresponding column does not contain a pivot. Look at this example. In the first matrix, the third column has no pivot. Therefore, the x3 is a free variable. In the second matrix, the second and fourth column have no pivot. So x2 and x4 are the free variable. In the third matrix, the third column has no pivot, which means x3 is free variable. Basically, if you find any free variable in the homogeneous system, you automatically know that it has infinitely many solutions. Thank you so much.